Hello, Robert Wohlfahrt here. And in the lesson today, we want to talk about links. We want to play around with links. We want to see how they work, how we can create them, and what are the differences between the symbolic links or soft links on one side and the hard links on the other side. Yeah. And I bet you have worked with links many times before in form of shortcuts, for instance, shortcuts to shorten the way from your desktop to a file or to a directory. But the links we talk about here are directly implemented within POSIX compliant file systems. Yeah? Every Unix system, every Linux system has these links. And let's talk about how these links are working, what they are, how we can use them. Yeah, and let's start with a little example, with a small example for a link. Let me share my screen. You should see my screen here, and I'm logged into a remote system, and I want to show you a symbolic link at first. We have on the system a directory called var mail. And this is the directory where all the mailboxes of the local users are stored. So if a local user on the system gets an email, then this email is stored within the file for this user, within the mailbox file for this user. Yeah. So for instance, let's touch a new file for a user called something, for instance. Yeah. This is the content of the directory var mail. Yeah. So now let's go into another directory. Yeah. Once upon a time, the makers of Linux distributions decided that the var mail directory isn't the perfect place for storing the user mailboxes. Yeah, they decided that it would be better to store user mailboxes within var spool mail. Yeah, and as you see here, the directory var mail is exactly the same directory as the directory var spool mail. Yeah, so if we change the directory, if we say from now we want to store the mailboxes in another directory, then we would have to take care of all the tools that use these files within this directory. Yeah, but if we use links, if we link these directories together, then it doesn't matter if we take the old directory to reach the user mailboxes, or if we take the new directory, the new name for this directory. Yeah. And this is implemented with links. We have within the var directory, we have a symbolic link. We have a symbolic link called mail, and this symbolic link shows to spool mail or points to spool mail. Yeah. So if I am within the directory var and I go into directory mail, then this is the same as going into the directory spool mail, yeah, because of this link. So we take links, or we use links to make a smooth transition, for instance, from one place to another, yeah, to leave the old name of a file of a directory intact, for instance. This is one reason for using links. And this here is a symbolic link. We have symbolic links or hard links or soft links, and we have the hard links on the other side. Yeah, symbolic links, soft links on the one side, and hard links on the other side. To understand what the differences are and how they work, we need to understand how files are stored within the file system. And for this, I've prepared a little whiteboard, yeah, how to store a file. How a file is stored on the file system. So if I store a file on the file system, yeah, then I write data blocks to the file system. So I have data blocks on the file system written to the disk. But these data blocks aren't a file by itself. These data blocks aren't a file by itself. They need a descriptor. They need some object, some type of object that describes a file and that describes that these data blocks are the file. So we have data blocks. These data blocks are completely anonymous. And then we have an inode that describes a file. And this inode gets first a unique number. Every inode has a unique number, let's say 1, 2, 3 here. And then the inode contains all the meta information we need for the file. Yeah, we need a permission, we need an owner, we need a timestamps, for instance. Yeah, there are some others, but the most important one here is the pointer, or are the pointers to the data blocks. Yeah, we have an inode with all the meta information for a file, and this inode contains pointers to the data blocks. So now we have a file, but this file doesn't have a name. This file doesn't have a name. Where's the name of the file? The name of the file is within a directory. So if we need a name for a file and we want to have a name for a file, then we need a directory. And within this directory, we have the name for the file. In this example, the directory home max, for instance, and we have a file name a.txt. And this file name a.txt is connected to the inode. It is connected to the inode 1, 2, 3. Yeah. So in this way, a file is organized on the disk. Yeah, we have the data blocks, we have the inode that points to the data blocks, and we have the directory entry that simply gives a name to the file. So, and now let's say we want to create a link. We want to create a link to this file. Then we create a second entry, a second file name within a directory or within another directory. And this second file name points to the first file name a.txt. And this is a symbolic link. This is a symbolic link or a soft link. We have a file system entry. Yeah, we have a name for a file. And this name doesn't point to an inode. This name points to another name. And this is a symbolic link. So if you open a.txt with the editor or another tool, yeah, you open a.txt, then the system straight goes to the inode 1, 2, 3 and reads the data blocks. If you open the file b.txt, then the system first goes to the file a.txt, then it follows the inode or follows the pointer to the inode 1, 2, 3, and then it opens the data blocks. Yeah, so we have one step more in the process by opening a file. But for the user space processes, for the VI, for the cat command, whatever we use, yeah, to access the file, this is completely transparent. Yeah. So this is a symbolic link. This is a soft link. Now let's talk about a hard link. What is a hard link? A hard link is, again, an additional entry, an additional name for a file, but this time the name points to the inode. This name points directly to the inode. Yeah, we can say that a hard link is an additional name for the same file. Yeah, so we have symbolic links and we have hard links. The symbolic links simply points to other name, and this name then hopefully points to an inode, and the hard link is a file system entry, a name that points directly to an inode. Yeah, so let's do this directly at the command line. Let's play around with links. Yeah, first let's create a file. First, let's go into my home directory. Here I am. And now let's create a file. Let's create a file, echo hello, and let's write this into a.txt. So now we have a file with the name a.txt. Yeah, hello was written into the data blocks. Then we have an inode. We see this inode with ls-i. Yeah, ls-i shows us the inode of the file. So a.txt is represented by the inode with this huge number here. Yeah. And then we have within the inode all these meta informations. Yeah, timestamps, permissions, ownership. These are the informations that are stored within the inode. Yeah, a.txt points to the inode with this number. This inode number contains all these meta information, and then a pointer, additionally, a pointer that points to the data blocks, and the data blocks contain hello. Yeah. So now let's create a link. Now let's create a symbolic link first. Yeah. And to create a link, doesn't matter if a symlink or a hard link, you use the command ln. Yeah. The command ln is for creating links. So create a link by targeting your link target. Yeah. The ln command always gets at minimum 2 parameters. First, the target, where the link points to. I create a link that points to a.txt, and the second parameter is the name. How should the link be called? And let's call the link a.txt underline soft, because I want to create a soft link, a symbolic link. Yeah. And to create a symbolic link, I have to add an additional parameter. I have to add -s. Yeah, ln-s a.txt underline soft creates a link a.txt underline soft pointing to a.txt. Yeah, this is a symbolic link. By the way, I use a lot of command line tools here. Yeah, if you want more about such tools, you can simply go to, perhaps you know it, shelltoolbox.com and get my free PDF, the Shell Scripters Toolbox. Yeah, go to there. You need to register with your email, and I will send you the Shell Scripters Toolbox directly into your inbox. Yeah, shelltoolbox.com. Get your free copy there. Back to our links. Yeah, I have created a link. Let's see if it worked. Yes, it worked. We have a.txt underline soft. This is the soft link that points to a.txt. Yeah? The shell here, the ls command here, recognizes that this is a link. This is a symbolic link and shows exactly where the link points to. Yeah. And now let's create a hard link. Let's create a hard link again with the ln command. ln. Let's create a hard link pointing to a.txt. And I want to name this time the link a.txt underline hard. This is now my hard link. Yeah, voila. Let's see if it worked. Yes, it worked. We have a.txt underline hard, and a.txt underline soft. And all three names can be used completely transparently to reach the content of the file. Yeah, I can do a.txt, cat a.txt. I can do an cat a.txt soft and a.txt hard. Everything, every name works the same here. So what are the differences? What are the differences in using these links? Yeah. So let's start by removing the original file. Let's start by removing a.txt. Now, before removing the file, let's see that this is a hard link. This is a hard link that points to the same number. Yeah, this is the number that stands behind a.txt, the inode number, and a.txt underline hard points to the same inode number. Yeah, So, and now let's remove the original file a.txt. What will happen? If I access the file with the name a.txt _heart, everything still works. Yeah, this is because a.txt _heart directly points to the inode. Yeah, we removed a.txt, but not the inode itself. Yeah, the inode itself and the data blocks, they weren't removed. Yeah, because what you see here, this column, the 2 here, is the link counter. This is the link counter. This is a counter that is stored within the inode. And this counter shows or says how many links, how many file names point to this inode. And this inode is only then deleted if the pointer reaches 0. Yeah, I removed a.txt. I still have access to a.txt _heart, yeah, still with the same inode number, but this time now with the link counter 1. Yeah, it is decremented to 1, and because it's greater than 0, yeah, the blocks and the inodes are still there, so we can simply access the file with cat, for instance. What with the soft link? Yeah, we have removed a.txt, so the soft link points to a file that doesn't exist anymore. Yeah, the shell sees that, or the ls command sees that. So if we call ls-l, a.txt _soft is now a so-called dead link. This is a dead link, a link that points to a file that doesn't exist. Yeah. So if I do, for instance, a cat a.txt _soft, yeah, then I will get a no such file or directory. Yeah. Okay. So how to restore the original way it worked, where it worked? Yeah. Let's simply create a link. Let's create a link pointing to a.txt _heart and name this link a.txt. ln. Let's point this link to a.txt _heart and let's name the link a.txt. And voila, the soft link now points to a file name that exists. It isn't a dead link anymore, and a.txt now again points to the original inode with this number. Yeah, it's the same number as here above, or way more above, where we had the first test, the first listing of the links. Yeah, so you cannot say, if you see hard links, which name is the original one and which is the link. You can't say that. You can't say that. Yeah, you only see you have 2 names, and these 2 names point to the same inode, point to the same content. Yeah. If you have a soft link, if you have a symbolic link, then you see that points to another file, to another path. Yeah, you can create symbolic links to files within another directory. Yeah, you can, for instance, do an ln-s etc passvd. Yeah, now I have created a link passvd with the name passvd that points to etc passvd. Yeah, again, ln, first parameter is the target where the link points to, second, the name of the link. Yeah, works perfectly. So what are the differences now here? What are the most important differences here? If I could choose to take a symbolic link or to take a hard link, I would prefer to use a hard link. Yeah, just because if I want to remove a file, I don't have to think about if there are other symbolic links pointing to this file. Yeah, if I use, instead of symbolic links, hard links, then I will still have access to the content of the file if I need access. Yeah, but we have two things to keep in mind if we are using hard links. The first, hard links are pointing to inode numbers. Yeah, hard links are pointing to inode numbers, and inode numbers are only consistent within the same file system. That means within the same disk. That means within the same partition. Yeah, so you cannot hard link a file between partitions, between disks. Yeah, that won't work. Yeah, for instance, I cannot do an ln dev null, for instance, and name this file dev null. I want to have a link within my home directory to dev null direct. I will get an error, invalid cross-device link. That won't work. Yeah, because the dev directory is on its own file system with its own numbering of inodes. So I cannot let a file system entry point via an inode to another file system. That won't work. Yeah, you can surely use a symbolic link. This will work perfectly. Yeah, ln-s dev null dev underline null. Yeah, will create a symbolic link with the name dev null pointing to dev null. Yeah, works perfectly, and I can use this link. Yeah, so this is the first, I would say, disadvantage of a hard link. You cannot hard link between disks, between file systems. The second disadvantage is you cannot link to a directory. Hard links to a directory aren't supported. Yeah, hard links are not allowed for directories. That won't work. Yeah, surely I can use again a symbolic link. I can use a symbolic link, etc soft or symbol will work perfectly. Yeah, I can now go to etc soft and do what I want to do. Yeah, so and because you cannot let a hard link point from one file system to another file system, and you cannot point or you cannot create a hard link to a directory, you will typically see symbolic links. You will typically see symbolic links, and you will see a huge number of symbolic links. Yeah, let's take, for instance, the etc directory. Let's take the etc directory and let's search within the etc directory for symbolic links. Yeah, find etc-type L. Let's find for symbolic links. Let's do this as the root user and let's see what happens. And you see a large list of links within this directory. Yeah, and let's count them. Sorry. Yeah, we have here 109 symbolic links within the etc directory. Yeah, you see the distribution, the Linux system makes heavy use of this symbolic links. Yeah, and let's take another directory. Yes, take the directory USR, for instance. Oh, here we have 867 symbolic links. Yeah. Again, as a reminder, if you need more information about such tools, yeah, go to shelltoolbox.com, get your free copy of the Shell Scripters Toolbox. Yeah. So, okay, you should now know the differences between a symbolic link and a hard link. Yeah, when to choose a hard link, when to choose a symbolic link. Typically, you will choose a symbolic link if you want to create a link. And sometimes, if you, for instance, want to have a second name within the same directory for the same file, yeah, for whatever reason you have, then you can use hard links. But typically, you will use symbolic links if you create them, and you create symbolic links with ln-s and then the target where the link points to, and then the name. Yeah. I hope you enjoyed this lesson. If you enjoyed, let me know in the comments. See you next time.